Okay, hello everyone. We are Dan and Valentin. We come from a long trip from Argentina. We are computer science students, but we work with an interdisciplinary group of economic people. So, well, I will start with some things before the hard part of the talk that I think that is the thing that you want to see. First one. Well, machine learning have been used for predict variables, but we prefer put focus on our work in econometrics. Why? Because a lot of economics needs to see the causal interface for making decisions. But what is this community needs? Well, ensample and upsample optimally. What is ensample and upsample? Ensample is a subset of data to get the estimations. And the upsample is another subset of data to see if the previous estimation is okay. It's like a test set and validation set in machine learning. Also, parsimony. They need the simplest model, like keys. The third one, okay. The economist needs to see the result, analyze them. They need to see if the weight of the variables makes sense across model sensitivity analysis. Okay. The model must consider the time, and the result that we have today must be able for tomorrow. And the last one, economists must check the result using statistical properties. For example, the t-test, the amount of observations, and so on. Well, okay. Of tools to get this information with two families. The first one is exhaustive search that is use a large amount of data, and the other one is the heuristic search that use an algorithm to filter the data before first. Okay, so we have some in Stata, NR, OX, Gauss, and so on. Our team create GSReg for Stata. But we have a problem with that. Why? Because Stata is primitive. And if you don't know, Stata is data analysis and statistic software. And GSReg is open, obviously. But because we don't want to use primitive software, we port it to Julia. GSReg. GSReg is a new package to perform ultra-fast subset regressions. It has a very simple interface, a command line interface, to get the information, and also it's compatible with the way that R and Stata select the variables. But there is people that has not the knowledge to coding. The economists nobody, I don't know, a lot of economists coding, but know all. So we create a more simpler way to retrieve the information.
Perfect. We focus in the migration from GSReg Stata version to Julia version, and we help to that users that Alan said with that migration, doing a graphical user interface. The steps that you can see there are the steps that the process of GSReg in Stata need. So the steps are load database, select the variables, tweak some settings, do the processing, and iterate all over again over the results. It's like us when we are coding, but with a graphical user interface. So we have a quick demo in a video to see how it works. You can put an CSV file, it's our first version, and you can select the dependent variables and explanatory variables. That's the selection. You can order it too, and after you can order the results and select the best model with that criteria. That's solving, and there is a little resume, but that helps us to know if the model is the best, and you can download the data to a CSV and open it with Excel and iterate over that result. So this graphical user interface We did it entirely in Julia, the backend, primarily, and we have a lot of features interesting features, like non-blocking communication between front-end and backend, using WebSockets that allows to have a lot of multiple users concurrently, and we have a task manager that allows to sometimes leave it in the cloud. That's our goal. The best part of all is the backend is done with Julia, with all the package of the community. Okay, the best part of presentation is the benchmarking. We did it in 3 platforms: Stata, Julia, and R, with the libraries, equivalent libraries. So, in our first experiment, we get in Stata 941 seconds. It's a simple example, and in R we get 144 seconds, and of course in Julia. It was amazing. We thought it was an error, but it's fine. So let's see the details about this benchmarking. First of all, the environment is a normal desktop PC with 4 cores and 8 threads. And we can see here that Julia is 8 times faster than R, and 50 times faster than Stata. And that is only one core. With, I know if I laser, with 8 cores, it's more faster. It's 4 times faster than R. So, conclusion: the dataset is too small in this test because we have no scalability. So we go further and increase the infrastructure and the dataset to test it. In this time, R failed, crashed totally. It cannot give a result. So in Stata took like 5 days. It's that number. It's worse. And in Julia, in 80 seconds, we get the result. It was incredible. So there is a few things to see here. We have a little scalability from 1 to 16 cores, so we increase more the dataset. In this time, the other language is out of league. It's out of game. It has no results. It takes like a week, and we stop it. So in Julia, we have the results. In 1 hour, 30 minutes, we get the result. And if we scale it, we can get 5 minutes. It's an important thing to see here is the superlinear speed up. It's 100 and a little more efficiency, so it was amazing. And we can see from 16 to 32 cores that the efficiency drops because this is a 16 core physically machine. Perfect. So now we can solve problems that we cannot solve before with Julia. It was amazing. Perfect.
Okay, some conclusions. First, we show an application in a field that is econometrics, dominated by commercial closed applications like Stata that takes, I don't know the price, but it's very expensive. The user interface was designed keeping in mind the ease to use. It's very simple. It's like Google Material Design. Largest datasets were out of reach for the other tools. R crash and Stata takes a life. Julia is really fast, really. And we used Julia to create an application for end users, including a GUI and web support entirely made in Julia. We know that we have a lot of things to do. We want to improve the package. We want to improve the interface, separate the UI to the command line. But it's a work in progress. And well, thank you. If someone have a question, there is no problem. I don't know.
On one of the first time
No, no.
Sorry.
Oh, okay, sorry.
It was this one, yeah.
Yeah.
So Julia didn't see much, if any, gain for the threads over here, going from 1 to 8. I didn't quite catch. Was there a reason for that?
The reason it's because the data set was too small, and there is a lot of overhead. So when we increase the data set, we can do help me do a
The overhead to loading all libraries and all the things takes so long, so the constant part of the execution is the most part of the execution. So when you increase the threads, you have a sequential thing that you can avoid. That's why when you move,
the parallel.
So are you talking about threads in Julia where you use like the threads macro, or are you talking about multiple cores?
No, we are using, at first we use threads, but we have some problems, so we now are using parallel.
Okay, so you spawn the work.
Yeah.
Okay,
Yeah,
that's
but
where you have the additional load time.
yeah, exactly.
Okay.
But you measure this time with load time or only the execution time?
We need to compare end to end because Stata use end to end, and so we compare. The CSV read takes a long time to load and read and make the data frame. So this is why when we move to a larger database, this constants is not taking a considerable time in the whole execution.
Yeah, I think we saw a comment this morning on what part of your application is parallelizable, and that sort of sets an upper bound on what you're going to get, right?
Yeah, I don't know.
No, I've seen similar issues.
Oh, yeah.
Like,
Yeah.
if you can do it all in one with the threads, like if you can do it in that for loop, like you can get some great gains. But if you have to use anything outside that threading loop construct and go to parallel, then you get the additional load times of
Exactly.
That was the first part when we said that you can order the pre-selection, the pre-data. So you can order, say, and select that data, and that loading time is reflected in that result.
The great thing is that Julia with 1 core is faster than Stata with 4 cores or R with 4
And
cores.
it can solve problems that Stata and R cannot with 25 variables.
Okay.
But
Yeah.
We have to move to the next speaker now.
Okay. We see you around, so we can talk in the.
thank you.
In the